Welcome to my channel. I'm Zhang Xu. Let's talk about problem 37 in chapter 3. In this one, you need to do a calculation to find the maximum of a horizontal range. So we will consider the maximum of the horizontal range. So this one is this one, right? So when you throw something, and then you can project the velocity into two components, x and y, and then it just the project motion hit there, and you can find the maximum of the horizontal range in this equation. Now we look at this equation, and this one is given in the textbook examples, and we can see the g constant and sine 2 theta naught and v naught squared. So it looks like there are only two variables, v naught and 2 sine theta naught, and they tell you to find the maximum of horizontal range. So the maximum of horizontal range. So one way we can find it, because for sine angle, so we know sine 2 theta must be in the range, right? Because the smallest, the theta is 0, so 0 is 0, and the sine value, the maximum is 1. So if we want to get the maximum of horizontal range, we can make the sine 2 theta naught equal to 1 to make it a maximum. Another one we can get quantity we need to decide is the v naught, the initial velocity. See, how can we find the initial velocity? It tells us if this is straight up, if it moves straight up and it takes 4.0 seconds to return the origin, it looks like this one. So we can see, can we decide the initial velocity? Yes, because the initial velocity, this one, initial velocity, at the peak, the velocity must be 0. Agree? And the y component must be 0. And because we can consider this up-through problems is mirror symmetry. So for the process, the initial to the peak, just 2 seconds. Do you agree? 2 seconds. So in this one, you can see you find the initial, you know the final velocity, and you know the acceleration pointing down, negative g, and you know the time. Can you find the initial velocity? Yes, very easy. Now let's see how I find it. So first thing, we can see it tells us it up through problems, right? It is straight up and 4 seconds. So this sentence help us to find the initial velocity v naught. So then we can find the v naught. Use this one, we can see the final velocity. The final velocity equals initial velocity plus at. T is 2. Acceleration is given, negative g. And also, the initial velocity y naught we want to find by this one is 0. In this case, we can find the initial velocity is this one. Now it tells us, this gun will do the project motion. What is the maximum of horizontal range? And for horizontal range, it is in this equation, and the v naught is given. We just find it. And this one, the maximum for the sine 2 theta naught. This one, the maximum for sine value must be 1, right? So we can consider this is sine 90 degrees, and then we get it around 40 meters. Thank you.